Good morning dear learners. Today I am going to discuss about the Unit 5 BSc Organic Chemistry. So before going to the topic, let us see the basics of chemistry. Chemistry is the branch of science which deals with the study of structure, properties, composition, reactions and the preparation of chemical compounds. Broadly, this chemistry subject is classified into 4 branches. One is organic chemistry, another one is inorganic chemistry, third one is physical chemistry and the fourth one is analytical chemistry. My topic is organic chemistry. First, let us see the definition of organic chemistry. Organic chemistry is the branch of chemistry which deals with the study of synthesis, structure, properties, composition and the reactions of carbon containing compounds. You know most of the organic compounds contain carbon and hydrogen, but they also contain the other elements such as nitrogen, oxygen, halogens, phosphorus, silicon, etc. Next is the importance of organic compounds. Organic compounds are important in the almost all the chemical reactions that takes place in the living organisms. Involves organic compounds such as enzymes, carbohydrates, proteins, lipids, fats, etc. Mainly the food we are taken is made up of organic compounds and the main reaction is the photosynthesis. It involves the organic compound and is also present in the medicines and the clothing. The petroleum, polymers, plastics, paints, fertilizers and the cosmetics are made up of these organic compounds. Next is the classification of organic compounds. In the universe, out of 100% of the chemical compounds, 90% of the compounds are organic compounds. So, depending upon the arrangement of the carbon atom in their structure, these organic compounds can be classified into 2 types. The first one is the acyclic compounds, or it is also known as open chain compounds, and the second one is the cyclic compound, or it is also known as closed chain compounds. First, let us see the acyclic compounds. Acyclic compounds are again classified into 2 types. The first one is the saturated compounds and the second one is the unsaturated compound. Saturated compounds. The definition of saturated compound means these are the compounds which have only CC single bonds in their entire structure is known as saturated compounds. Examples for saturated compounds are methane, ethane, propane, etc. Next, let us see the definition of unsaturated compounds. These are the compounds which contain 1 CC multiple bonds in their structure is known as unsaturated compounds. Multiple bond means it may be a double bond or it may be a triple bond. The example of unsaturated compound is ethene, acetylene, propyne, etc. These are some of the examples of unsaturated compounds. Cyclic compounds. Cyclic compounds are also known as closed chain compounds or ring compounds. It is defined as these are the compounds which contain carbon atoms connected to each other in a ring. It is known as cyclic compounds. Cyclic compounds are further classified into 2 types. They are homocyclic compounds and the heterocyclic compounds. Homocyclic compounds. If the ring structure contain only carbon and hydrogen atoms, these category of compounds are known as homocyclic compounds. Heterocyclic compounds. If the ring structure contain other than carbon atom, for example nitrogen, oxygen, sulfur, etc., these category of compounds are known as heterocyclic compounds. Now let us see the flow chart of classification of organic compounds. This is the simplified flow chart of the classification of organic compounds. Organic compounds are classified into 2 types. One is open chain compounds, another one is closed chain compounds. Open chain compounds are also known as acyclic compounds. These acyclic compounds are again classified into saturated compound and unsaturated compound. Now coming to the closed chain compounds. Closed chain compounds are also known as cyclic compounds. These cyclic compounds is again classified into homocyclic compounds and heterocyclic compounds. Coming to the homocyclic compounds, these homocyclic compounds are again classified into 2 types. One is alicyclic compounds, another one is aromatic compounds. These aromatic compounds are again classified into 2 types. One is benzenoid compounds and second one is the non-benzenoid compounds. Coming to the heterocyclic compounds, these heterocyclic compounds are again classified into two types. One is alicyclic compounds and second one is aromatic compounds. Organic molecules are often classified by the functional groups which are present in their structure. The functional groups are the characteristic arrangement of atoms which define many of the physical or chemical properties of the organic compounds. Alkane contains no functional group. Alkene contains C double bond C functional group. Alkyne contains C triple bond C functional group. Alcohol contains bond OH functional group. Aldehydes contains bond C double bond O bond H group. This is the aldehyde functional group. Ketone contains bond C double bond O bond group. Carboxylic acid functional group is bond C double bond O bond OH group. So these are some of the functional groups which are present in the organic compounds. Homologous series. The structurally similar organic compounds having same functional groups and a different number of carbon atoms are known as homologous series. The homologous series is characterized by the two adjacent members are differ by a CH2 group or 14 atomic mass units. Why it is called as 14 atomic mass unit means the mass number of carbon is 12 and the mass number of hydrogen is 1. CH2 means 12 plus 2 it becomes 14. So that's why 14 atomic mass unit. The second characteristics of homologous series is all the members of a series have the same general formula, same methods of preparation and similar chemical properties due to same functional group present. The third characteristic is the homologous series shows difference in the physical properties due to change in the molecular mass and the structural arrangement of the molecule. This is the homologous series. So first take the alkane homologous series. The general formula of the alkane homologous series is CnH2n plus 2. The first homolog is the CH4 and the second homolog series is the CH3. The difference between the first homolog series and the second homolog series is the CH2 molecule. So this diagram explains the homologous series of different organic compounds. Isomerism. For same chemical formula, we can write two or more different structures. For example, for a chemical formula C3H8O, we can write two to three structures. So the definition of isomerism is chemical compounds that have identical chemical formula but differ in the structural, chemical, physical properties are known as isomers, and the phenomenon is known as isomerism. Example for isomerism is the chemical formula C3H8O. It can be written in three different ways: CH3 bond O CH2 CH3, CH3 bond CH bond CH3 OH, CH3 CH2 CH2 OH. These three structures contain same chemical formula but different structural formulas. Here the first compound is the ether compound and the second compound is the secondary alcohol and the third compound is the primary alcohol. So this is the example of isomerism. There are two main types of isomerism generally observed in organic molecules. They are structural isomerism and stereoisomerism. Now let us first discuss the structural isomerism. The compounds have the same molecular formula but different structural formulas are called as structural isomers, and the phenomenon is known as structural isomerism. The structural isomerism is further classified into 6 types. They are: first one is chain isomerism, second one is position isomerism, third one is functional isomerism, fourth one is ring chain isomerism, fifth one is metamerism, and the last one is tautomerism. So these are the types of structural isomerism. First is chain isomerism. In this type of isomerism, the compounds possessing same molecular formula but differ in their properties due to the difference in the arrangement of the carbon chain present in the molecule. For example, a molecule having the molecular formula C4H10 can be written in two different ways. One with all the 4 carbon atoms are in the same chain. This structure is known as N-butane. In other type of connectivity, the 3 carbons are in the same chain and the 4th carbon is attached to the middle one. So this structure is called isobutane or 3-methyl propane. In order to show chain isomerism, molecule should contain at least 4 carbon atoms. The molecule having less than 4 carbon atoms do not show chain isomerism. Next type of structural isomerism is position isomerism. In this type of isomerism, the compounds possessing same molecular formula but differ in their properties due to the difference in the position of either the functional group or the multiple bonds or the branched chain which is attached to the main carbon chain. For example, the molecule having molecular formula C5H12O can exist in 3 different alcohol structure. This structure 1, 2 and 3 have same molecular formula and same number of carbon atoms in a structure, but in a structure 1 the OH group is attached to the C1 position and it is known as N-pentanol or it is also known as 1-pentanol. In the structure 2, the OH group is attached to the C2 position, that is known as 2-pentanol. Similarly, in the structure 3, the OH group is attached to the C3 and it is called as 3-pentanol. So, the structure 2 and 3 are also called as isopentanol. All of these alcohols are different in their physical and chemical properties. So, it is important to note here that aldehydes, carboxylic acids and their derivatives, cyanides do not exhibit position isomerism. Also, monosubstituted alicyclic and aromatic compounds also do not exhibit this position isomerism. Next type of structural isomerism is functional isomerism. In this type of isomerism, the compounds possessing same molecular formula but differ in their properties due to the difference in their functional group. That is, the functional isomers differ in the functional group present in them. For example, molecule having molecular formula C2H6O can exhibit at 2 different functional molecules. First molecule is ethanol and the second molecule is methoxymethane. In the first molecule, the heteroatom oxygen is attached to the hydrogen and CH3CH2 group, hence it is an alcohol. In the second molecule, the oxygen atom is attached to the 2 CH3 groups, hence it is an ether. Thus, alcohols and ether having more than 2 carbon atoms show functional isomerism. Similarly, aldehyde and ketones, carboxylic acids, esters, cyanides, isocyanides, alkane, nitro compounds and nitrate compounds also shows functional isomerism between them.